Welcome to the Gold Coast Trade College Introduction to Working Safely at Heights. This lesson will give you a short introduction into some of the requirements for you to be able to work safely when working at heights. We'll start with what is working at heights. The definition, as you can see on your screen, is basically a person falling from one level to another. So your employer must ensure that he has duty of care to provide a safe workplace to stop you from falling from one level to another. You will notice there is no specific measurement of height written in that, as recent studies have shown that there is no specific height that you can fall from that is more or less likely to cause injury. So that way they've put one level to another, meaning that you can fall from a lower height and still cause serious injury to yourself or others. Right, in particular, the measurements start coming in when you're looking at high-risk work activities. So anything below 2 metres, when you're working from where your feet are, anything below 2 metres is not considered high risk. Anything greater than 2 metres is considered a high-risk activity. And you will remember from previous lessons that anything that is a high-risk activity will require a set of SWMS or a safe work method statement prior to commencing the job. So like anything, we need to conduct a job safety analysis to have a look at the risks and the hazards that are involved, and we can look at potential control measures of how we're going to mitigate that risk. So similar to your previous lesson on work health and safety, you'll remember the hierarchy of controls. Right? That is the process that we use to deal with a hazard. There is a similar hierarchy, specifically in regards to heights. This hierarchy is called the hierarchy of falls prevention, and we'll go through that together now. So starting from most effective to least effective, level 1 is working on the ground or solid construction. All right. So the definition of solid construction is it must have the capacity to support workers, materials, and the loads, even non-slip surface of a gradient less than 7 degrees, appropriate edge protection, and safe access and egress. All right, so some of the examples you'll see on your screen there consider solid construction or just as safe as working on the ground. All right, that level 1 control there is basically saying that if possible, if you can avoid working at heights, an example of that might be instead of working on a platform ladder to fix a light fitting, it may be safer to remove the light fitting, go up the ladder, remove the light fitting from the roof, work on it on the ground, and then reinstall. That limits your exposure to being working at heights, therefore controlling the risk of falling. Level 2 is known as passive fall prevention. Right? Passive fall protection is temporary structures that allow you to do your job without the risk of falling. An example of that is scaffolding and EWP. This is a confusing one. A lot of people think that EWP comes in the next category. However, EWP, because of, if you look at the centre picture on your screen, if you have a look at the basket, the actual handrail heights around the basket comply with Australian standards for handrails, meaning the top rail is between 900 and 1100 millimetres off the ground, and you have a mid-rail as well. So once you're inside that basket cage, you're technically inside a temporary handrail. The picture on the left is perimeter protection that we use for residential roofing. We'll go through that again a little bit later, as it's not appropriate to wear a harness on a residential roof. And the picture on the right is scaffolding. So all 3 of those are examples of passive fall protection. So scaffolding is a temporary structure that provides a safe means of access during the work or construction of a building. All right. There's 3 types: modular, mobile, and edge protection guardrails. I'll have a look at them in detail now. So scaffold, you have 3 levels, actually have 4 levels: light duty, medium duty, heavy duty, and those all have a specific kilo rating for each bay. Right? It's very important that you check the tags prior to entering the scaffold stairs to know what scaffold is, what your bays are weighted for. Right? So light duty means no materials to be stored on there at all. Right? 225 kilos per bay is basically 2 operators, not much more. When you start putting 2 people plus their tools in there, there's no room to stack materials. Right, so like I said, there's a compliance tag on the stairs before you enter a scaffold. You need to check not only that it's in date, it's been inspected and compliant, You need to check the weight rating of it prior so you know your limitations for that scaffold. We have modular scaffold, which is a course that you'll do here at the college. Up to 4 meters yourself can be installed without having a specific license. So it's usually aluminium. Most of the stuff you'll use now is from a hire place, aluminium scaffold, and you erect it yourself. It's on fixed cast, so it's on solid casters, so you can move it along the side of a building. There's an example there in the picture. Caster wheels must be solid. They can't be pneumatic. That way, if one of the wheels can't deflate and put you out of balance when you're on the scaffold. One of the main safety points to note with a mobile scaffold is that you must not be on the platform while it's being moved. You must completely exit the scaffold before it's moved. Edge protection guardrails, as you can see in the picture here, they are for residential roofing. They have provided a temporary border around the roof to allow the workers to sheet or insulate the roof without falling off. It's not appropriate to wear a harness when you're on a residential roof, mainly because the distance between the fall and the ground is not long enough for your harness to be effective. These systems are temporary. They get bolted in under the eave structure there, as you can see in the photo, and only there for while the roof is being sheeted. Next one we have is level 3 work positioning systems and travel restraint systems. Work positioning systems allow you to work on a live edge without the ability to possibly fall off. Meaning your rope or your harness point is limited to a distance that does not allow you to fall off the roof. So as you can see in the diagram on the right, that person is anchored to the centre of the building, and it gives him a radius in which he can work from. It's not possible to anchor off a single anchor point like he is there and work in the corner of the building. Because of the pendulum effect, he has the ability to fall off the side and drop even lower. If you want to work parallel to a surface, you need to set up a static line, which is in the bottom picture on the left. That allows you to run your line parallel to the surface that you're working to. But a single anchor point, like in the picture on the right, you have to be very aware that your radius, you need to work off a radius. The 4 main components of your fall arrest system, your fall prevention system, is your anchor point, which is number A in this picture, the harness, which is what you're wearing, snap lock connects you to the harness, and your D-clip, which is on the back of your harness. Level 4, fall arrest systems. This level is assuming that the fall is highly likely, and there's no other restraints are possible. So this is, as we're getting further down this list in the level of hierarchy, we're getting less and less more effective. So when you're in fall arrest, you are acknowledging the fact that there's no other option but to work in a way that allows you to possibly fall off the edge. This is definitely a high risk activity. It requires a SWIMS, job safety analysis, and also you will be required to do a rescue plan so that everyone involved understands the process of how you can be rescued. So there's 3 ways of putting yourself into fall arrest. One is a catch platform, as seen in the bottom left picture. It's basically catching you from falling, or tools or materials. Safety net is again on the top right photo. That looks like it's an oil rig setup, where they're working there. And if they were to fall, it will catch materials, tools, and potentially a person. And the third is what you guys will be using in the practical activity when you attend the college. And it's an individual fall arrest system. It's shown in the bottom right photo. That is a harness system with a shock absorber attached to it. So if you do fall, the shock absorber will take some of the impact off the weight of the fall. It stops you from potentially breaking your pelvis. So we'll go through these components now. As I said, this is the practical task that you guys will be doing when you come to the college. So the IFAS, or the individual fall arrest system, components are the harness, which is the bottom left photo, lanyard with the shock absorber attached, or energy absorber, carabiners, and the connection points. In this case, that's a single anchor point that's bolted to a surface, and this is a static line here that allows this operator to work parallel to his anchor point. Right, as I said before, if you are using a fall arrest system, you need to have a SWIMS or a rescue plan to be able to rescue that worker within the time frame of 5 minutes. The magic number of how long you can hang for suspended in a harness before you do serious damage to your body is 5 minutes. So in your rescue plan, it must be a detailed plan of who is responsible, what methods they're going to use, how they're going to communicate, and how they're going to conduct a rescue within 5 minutes. If you can't achieve that task, then you cannot carry on with the activity. All right, so this is going to come up in your question book. This is how we calculate the distance required for fall clearance. All right, so if you have a look at the diagram on the right, the distance between the anchor point and the ground, the lanyard length is approximately 2 meters in this case. That's from the center of the back to the anchor point. So this distance here is 2 meters, giving you 2 meters to start with. We then add the shock absorber length once it's fully deployed. So what the distance as that stitching breaks in your shock absorber and it extends to slow you down, we need to add another 1.75 meters to that. The next one is subjective to the person, but the average body height is 1.75 meters. If you're shorter or taller, you'll need to take that into account there. So we're adding 1.75 from, again, the top of the D clip once you've been suspended down to the bottom of your feet. And then we need to add another 1 meter for clearance, of stretch clearance of the entire system. So as you can see, if we add all those total numbers up, we need a possible minimum height of 6.5 meters from our anchor point to the ground before this system is going to work effectively. If it's anything less than 6.5 meters, there's potential for you to still hit the ground as you take a fall. And as I said before, this is why this system is generally not used on residential roofing, because the distance between the anchor point and the ground is less than 6.5 meters. We'll go through a harness inspection after this in a practical demonstration. The final level in the hierarchy of falls prevention is level 5, ladders and administrative controls. We're at the lowest form of control at the moment. So ladders are generally considered one of the most dangerous ways to work at height. Most step ladders are banned from commercial sites. You'll be required to use a platform ladder or use a ladder purely for access. The main reason that it is unsafe is because one of the rules of climbing a ladder is you must maintain 3 points of contact at all times. So it's quite hard to maintain that 3 points of contact if you're attempting to do work off a ladder. So tools need to be passed up or used a rope and pulley to access the height area so you can effectively climb the ladder without breaking those rules of 3 points of contact. All ladders must comply with Australian standards. They all must be rated to 125 kilograms, and they must be set up in the correct way for you to use. So there's a couple of points here on the right. Always climb and descend facing the ladder, and always with 3 points of contact. When you're setting up a ladder, as you can see in the photograph here, the ideal ratio is 4 to 1, meaning for every 4 meters in height, you need to bring the base out from the wall 1 meter. It also needs to extend past the roof 1 meter to allow yourself access to get off the roof and hold on to the ladder at the same time. You need to make sure that the ground is level and stable, and the ladder needs to be attached at the top or the bottom or both. So all those points there are covered off. Make sure that you put safety barriers around the base of your ladder if you're on a walkway or an access way to prevent any machinery or people moving the bottom of the ladder while you're climbing. So that's a really quick introduction there on the hierarchy of falls prevention. What we'll do in the next segment is we will give you a demonstration of how to fit a harness and also how to inspect a harness for serviceability. The next part of the video, we're going to be showing you how to conduct a harness inspection. This inspection will need to be done prior to and after you complete any working at heights activity. Right, I've got Pat with me here. He'll take you through a demonstration of what you need to look for. Pat,
okay, so the basic inspection for a harness, what we usually do is the first thing we look at before we do anything, any actual visual inspection, is the compliance tag, which will be located in the shoulder strap. Okay, so if we open this bit of Velcro here, what we've got some tickets there, and you'll find the compliance tag usually on the back. Okay, so that compliance tag usually has the date of manufacture and also the expiry date. Okay, also the Australian standards, if it complies with Australian standards. Okay, so if you look for that AS/, and also there should be a destroy date also on that tag there. Okay, so that's the main thing. As I said, it'll be located in the shoulder strap. The other things that we have to identify and look for on the harness, okay, it's best to always hold it in the correct position when you're inspecting it. So key factors are, okay, to see if the stitching is okay. So we go right over the stitching to see that there's no fraying or rips or tears in the actual harness itself. Okay, obviously wear and tear depletes the fabrics over a period of time. There is a little bit of fraying there on the strap, so they're the key factors you look for. And also the buckles, okay? So with the buckles, we've got to look at whether there's any warping or pitting. So go right over these buckles here, okay? Just a thorough inspection. And just remember the whole time you're doing this, if you're going to wear this harness, you've got to make sure it complies with all these safety standards. Otherwise, you can rip and tear. And if you're suspended, okay, from a height, it could be possible that if the stitching is loose, or if there's signs of fraying, there is a possibility of that to rip, and you can come through with it. Okay, so they're the general things you look at. Also the carbinia. Okay, so you've got to make sure that this gate, okay, snaps back into position and locks. Okay. And also on the carbinia, the same thing. Any signs of threading or the stitching coming apart. Okay, so once you've had a thorough inspection of your harness, just move on to the lanyard. Okay, the lanyard, when it's fully stretched, it's usually 2 meters. And then if you have a look on this compliance tag here, it'll actually say how much the absorber, the shock, this is the actual shock absorber. Okay, so that is dispersed once your weight has been, if you're falling from a certain height, this is released the shock absorber, and it just stops. That's exactly what it is. It's a shock absorber. So it stops the shock of all your weight dropping all of a sudden. Okay. So on this compliance tag, the same thing. You've got date of manufacturer, also when its life expires, and also it's good to check these hooks. Okay. So all those key points, just remember you're the person wearing this harness, so make sure you do a thorough inspection. Thank you.
Right, thanks, Pat. As Pat said, this process needs to be done prior to using this harness in any way. Right, it needs to be done thoroughly because this is a piece of equipment that's going to save your life in the event of an accident. So make sure you do it properly and make sure if you're not happy with it in any way, that you tag it and report it and get a new harness. They're not expensive, especially the cost of a life. You need to make sure you're happy with your equipment before you use it. Right, the next part we will demonstrate is how to correctly fit the harness. All right, the next part of the lesson we'll talk about fitting the harness correctly. Right, if these are not stored correctly, they can get all jumbled up and mixed up, and you can easily get lost as to where it is. The easiest part is to locate the dorsal D-ring. This part goes in the centre of your back, right, as you can see there. Holding it up right there, you'll be able to identify straight away the shoulder straps and the leg straps. Right, so holding it up, the webbing there goes in the centre of your back. Right, the mesh there is generally in the centre of your back. So we're holding it up, right, shoulders through. Right, straight over that. As you can see, our tags, we've already inspected it to make sure we're happy with it. Right, it's located on the shoulder. Chest strap goes on first, right, feeding the buckle through, making sure that there's no twists in your harness. Right, just like a seatbelt in your car, you don't want your harness to be twisted because it puts point loading pressure on that area, and that's how you can break bones, things like that. All right, this person, the last person to use this, was a little bit shorter than me, so you need to make sure that you adjust the height that's appropriate to you. All right, so you've got 2 on the side here before you start doing your leg straps. All right, these are a one-size-fits-all harness. That's why they have these 2 adjustment straps here to give you that different height. I'll just take a step back. All right, once you're happy with your chest strap fitted, you then take our leg straps. In this case, they're a different colour, so they're easy to identify. Round through the back. And back onto your hip. Right, again, you don't want to make sure that there's no twisting in that at all. Right, we'll do the same with our second one. Through the back. Alright, we've now got our leg straps attached. Right, the way we make sure that the harness is fitted correctly is we use the open hand, closed hand method. Right? Just taking away all these excess back ends of the straps so they don't get tangled up when you're working. Alright, so the open hand, closed hand method is you take an open hand to the opposite leg, feed it through the leg strap. Right? If you can feed it through with an open hand, if you can't feed it through with an open hand, it means your leg strap is too tight. Right? It's not going to be comfortable, you're not going to be able to stand there for a while and conduct the work. Once your hand is through, close your fist. If you can pull it out as a closed fist, your leg strap is too loose. Right? So we now need to tighten that up. Right? At the same time, we need to make sure we can still have a full range of movement so we can work effectively. Right? So again, I'm going to test that. Open hand through, close your fist, attempt to pull it out. Nothing comes out, so we're happy. Right? We've now fitted the harness correctly. Right, what we'll do is we'll get Pat to help me hook up this. Right, shock absorber goes into the middle of your back. Okay. And the excess end before you hook on can just be located on your chest D-ring, just to stop you from tripping over. Right? You should, as I said before, you should still be able to conduct a full range of movement, but you shouldn't have too much pressure on your legs to make it uncomfortable. Right? This harness here has an added feature that's not on all of them. You can see these little bags here. Right? These little bags here are how you can conduct a self-rescue. Right? So as I said previously, you need to be rescued within 5 minutes when you're in suspension to stop the arteries in your legs being cut off for too long. These two little bags here, if I open them up, if I'm now suspended, I can open that up, deploy the strap, this strap here. Once it comes out, make a loop in it itself, and I can now put my foot in there. Once it's hanging down beside me, I can put my foot in there and stand up in the harness and take the weight off my legs. Right, so if I'm still hanging there and someone can't get to me within 5 minutes, I can effectively self-rescue because the pressure is off my legs, and I can stay suspended, standing up, as long as it takes for someone to make the rescue.